Welcome to beautiful sunny San Diego. San Diego had 35 million tourists last year due to our lovely beaches and of course many attractions. This is our Miramar landfill, a site that's not on the list of popular San Diego tourist destinations, but of course every populated area needs a landfill. Tourists and residents generate nearly 1 million tons of trash per year here in San Diego. As a chemist, when I look at these trash piles, rather than thinking of the smell or the mess, I like to think of the opportunity. Trash is chemically complex. What if there was a way to separate the elements and compounds in trash and use them elsewhere? The folks here at the landfill already do this to some extent. Trash generates methane gas when it decomposes, and here some of that methane is captured using pipes to power 2 nearby facilities. A good amount of the methane does escape to the atmosphere, however, which is unfortunate since methane is a contributor to global warming. Could we use chemistry to improve on methane capture? And what about the rest of the trash remaining after this partial decomposition? Complex separations could benefit from new complex materials that are highly tailorable and highly absorbent. In the Benz lab, we study metal organic frameworks, or MOFs for short. MOFs are both absorbent and tailorable new materials that can capture and store gases like methane. This is because MOFs are like little nanoscopic sponges. They typically form nanoparticles with holes about the size of a molecule, which is what makes them so absorbent. This is a normal sponge. And this is a 3D printed MOF unit here. You can see the tiny holes in the structure of the MOF. Also, because of these holes, MOFs have very high surface areas, which makes them good at storing gas. In fact, the surface area present in this small vial of metal organic frameworks is enough to wallpaper a typical one-bedroom apartment. My group in particular is studying the surface chemistry of MOFs. We ask questions like, what sort of chemical groups appear at the outermost surfaces of MOFs? And do these groups exist inside as well? Does the surface chemistry have an effect on the performance of MOFs? And finally, can we control the surface chemistry to make MOFs more useful so that one day we may be able to use them in complex separations like the problem of trash that I mentioned earlier? I hope the answer is yes. We won't know unless we try, so back to work. Thanks for listening to this video. I hope you've enjoyed learning a little bit about metal organic frameworks.